All right, so you have a problem here. A tank's holding 1,000 gallons. It drains from the bottom in half an hour. The values on the table show the volume V of water in gallons and T in minutes. So I don't know what it looks like. If we wanted to have a figure of it, the head pressure must be making the flow rate change, right? And the water's spraying out. It starts, and the one they skip, it holds 1,000 gallons. So at times 0 here, there's 1,000 gallons, right? It's not shown in the table, but it's implied. And so we can do lots of things with this graph, all right? And it starts here with, if point P is 15,250, and this is where we were talking about, on the graph of the volume, find the slopes of the secant line PQ, when Q is a point on the graph, when T is 5, 10, 20, 25, 30. This is hard to read. Yeah, it's just, they're moving Q from here to here, to there, to there, to there. So everybody, I would rather figure out PQ, where Q is point P, V. You guys agree? And then I can just substitute all the points. So for letter A here, I would say, hey, I want to find the slope of PQ. And P is never changing, right? P is always 15,250. This is section 2.1 in Stewart. It's on page 69. Yep. Do you guys agree this is P? And right now, Q would be T, comma, V. All right, I'm going to do it in variables first to save us some work. We know it's rise over run. So rise over run is slope. Well, there's the slope PQ. All right, maybe I put that down here. And now, for me personally, I just would write the points below the formula. And the great thing about TI calculus is you should be able to substitute these as we go. All right, so the first point was 0.5, which was 5, comma 694. So you guys notice the volume is negative, or the bottom is negative 10, 5 minus 15, right? The top is whatever 694 minus 250 is, all right? And to me, it becomes obvious that it's going to be negative. But what's more important at this point is what? The units. This is gallons on top. This is minutes on the bottom. All right, I'm going to come back with my calculator. I'll pause the video here. We'll do them all at once because I'm just going to list all the points now. The next point I would do would be 10, 444. 444 minus 250 over 10 minus 15. Next point I would do would be, now it jumps to the other side, which would be 2111. And this is maybe where I pause, because all of a sudden the bottom is not negative anymore. But the top is right on, and that's an important fact for us to realize. All right, then we got 2528 as the next point. Which is 28 minus 250 over 25 minus 15. And these units are all the same, all gallons per minute. The last point is 3010. Go back to red, or 3010, 30. So that's 0 minus 250 over 30 minus 15. And now what I should be able to do for all of these values is just grab my calculator and do some calculations. All right, so what I want to do more than anything is I just want to put this in once and then change values. I notice that all my points are either 2-digit on the X or 3-digit on the Y. So when I do this, I'm going to enter this here like this. I'm going to go this. My first point is 694 minus 250 divided by, and it's 5, right? But since I know it's going to be 30, I'm going to put 05 in, minus 15. And the first answer is negative 44.4. All right? And I'll move that here in a second. Negative 44, because it's under the calculator. Negative 44.4 gallons per minute. That's the first one. Now, by going second equals, or second entry, it brings back the previous problem. Now what do? Well, I change the 694 to 444. And I change the 05 to 10. I hit enter. The next one is negative 38.8 gallons per minute. And I hit second entry, right? And the next point was 111 and 20, so I changed 444 to 111. I changed 10 to 20, hit enter. Negative 27.8 gallons per minute. I hit second entry, and actually this would go much faster if I didn't have to talk in between. And I would write in 028 instead of 111. I would write in 25. I hit enter. Negative 22.2 gallons per minute. Always a unit. And finally, I'd go back up. Last one, second entry. 000 minus 250 over 30 minus 15. Negative 16.7 is what I'm going to call it. Gallons per minute. I'll take a snapshot here of the calculator. Just get it out of the way. All these values now, this is letter A. Does it make sense that they're all negative? Yeah, why? It's emptying. Remember yesterday we had the graph, and today what I did is I went to Excel, and I just plugged in the little table like this, and I made the graph. I prep for class, I know. Don't count on it usually. And I actually copied that in here. I know. And here it is. It makes complete sense that the slope of the secant line is always negative. The tank is emptying. The gallons are flowing out with time. We can see that it's decreasing the whole way, and the secant lines are negative the whole way. Decreasing function, negative secants. A lot of work. We just did letter A. Welcome to calculus problems. So if I capture all this, and I group all this, and I make it small, that is letter A. Then it says, estimate the tangent line of P by averaging the slopes of two secant lines. So they want me to average P. Here's what I want you to notice. If I'm going to average P, we could add them all, but I think we just want to use the ones that are closest to P. So I want you to see, does everybody see that if we were trying to see where P was, it'd be right in here. Do you guys agree? So if I'm going to average two secant lines, I want to average the secant lines that are closest. So I'm just going to average negative 38.8 gallons per minute plus negative 27.8 gallons per minute divided by 2. And I would say that for letter B, the answer is going to be, I don't know, I guess I'm going to grab my calculator, 38.8 plus 27.8. You guys notice I brought, by what I'm saying out loud, I dropped the negatives on that, but I know it's negative. Negative 33.3 GPM. There's letter B. Makes sense to me. And then today, why I actually prepped ahead of time. Well, use a graph with a function to estimate the slope of the tangent line at P. This slope represents the rate at which the water is flowing from the tank at 15 minutes. So we got negative 33.3 by taking the average of the two secant lines on each side. And I'm going to show you on a graph what that looks like, okay? So we know the two lines are negative 27.8, and maybe dual page will work. From 15, this line was negative 38.8. This line is negative 27.8. When we averaged them, we got negative 33. If I take away those lines, I'm not really interested in that. I want to know the flow rate now. So if I go back to a single page, I really blow this up, and I get down to where I want to be, 15. I'm going to grab my line function and actually use smartboard line. see how well I do here. The great thing about a smart board is I should be able to move this around. I don't know, does that feel pretty good? I'm not feeling bad about that. Now the question is, well, I pause and answer the phone. We'll see if you guys agree with that line. All right. So everybody, I think it's pretty good. All right. So now, I love making my triangle large. Whoops. Everybody, I think that's 23 minutes. You guys can argue with me if you think it's something different. I think this is 710 gallons. And I have no idea. You guys see how I just made that triangle for the slope of the tangent line? I'm going to use my calculator because it's a nifty tool and I don't particularly like to do math longhand anymore. And everybody, it's going downhill. I got negative 30.9. You got negative 30? And again, those are all correct answers, gallons per minute. And it depends on, and I would say, and that's the answers, all right? And here's what I'll tell you. It depends on what you're doing, the level of accuracy you have to have. Listen, if you have a tank that alarms every time that the flow rate's more than negative 31 gallons per minute, it's actually a big deal whether it's negative 30.9 or negative 33. All right? Because I used to have a job where every alarm I had to go in. I would definitely want to know, right? Whereas if I'm just emptying a tank because I want the water out so I can put something else in, I don't particularly care. These both numbers are probably close enough. But again, this is the calculus. And what we have to do eventually is get away from doing secant lines and get to doing tangent lines. All right? Rate of change. We are figuring out how fast the change of water and the volume is happening.